old days. Or were they so good? For transport, the bumping, tiresome coach journey of 100 years ago. Or trains pulled by the streamlined 1857 model. The penny farthing bicycle. By 1910, we were progressing. Until today, we have efficient, comfortable modes of travel. The old-time farmhouse and fence were both hewn from the forest. Crops, too, were gathered by hand. But the farmer has also come a long way. Today, fencing, building materials, water piping are made by machines. Machines have taken the sweat and toil out of much of farm life. A metal we all take for granted has played a major part in this great transformation. A metal we call steel, the most useful metal in the world. Its mass production 100 years ago brought the dawn of a new way of life. Stand in any city street. Within your immediate vicinity, there is something made of or depending on steel. Obvious things are tram tracks, light poles, the framework of buildings, the thousands of cars. All the little knickknacks about the home, scissors, electric fans, stainless steel sinks, and a host of other things are products of steel. Even in a small room, there are sure to be many things made of steel. The lock on the door, the radiator, the steel cabinet, the electric clock. Even nearer and more personal, the stainless steel of your wristlet watch. Steel is a very versatile material. All modern machinery is made from steel. Steel shapes timber, weaves cloth, molds plastic. Steel enters our everyday lives, be it at home, work or play. Safety pins or the Sydney Harbour Bridge all have one thing in common: steel. A nation's steel output is a barometer of its prosperity. An assured steel supply a firm foundation for industrial progress. Australia is fortunate in having two major steel plants, the BHP works at Newcastle and the AIS plant at Port Kembla, together with adjacent associated heavy industries. This group has expanded hand in hand with the nation's industrial development. It is meeting a greater and greater demand for its product. From ore to store, the mini production processes must be under common management to ensure smooth working efficiency. The industry has its own raw material sources, which are as widely apart as coal mines on the Pacific coast to iron ore deposits in the far northwest of Australia. It operates its own fleet of 15 vessels, but so huge are its cargoes that this fleet can handle only 1/3 of its needs. Its first requirement is an adequate supply of good-grade iron ore. The major source has for many years been iron monarch, inland from Spencer Gulf, South Australia. Blasting brings down thousands of tons of ore, and huge electric shovels pick it up, 8 tons at a bite, quickly load it into waiting trucks. Electric locos haul the loaded trucks to the crushers. The ore is transported 34 miles to the shipping port of Whyalla. A trainload of 2,000 tons can be loaded in 1 hour. At Whyalla, the ore is stored in bins until the arrival of a vessel. It is loaded by conveyor belts running over the 2,300 feet length of the jetty. An additional iron ore deposit is operated at Cockatoo Island on the far northwest coast of Australia. Equally important to the steelmaker is coal suitable for making a good hard coke. The industry owns and operates 10 collieries. It is a heavy coal consumer, using well over 3 million tons yearly. 3 tons every minute of the day and night, day in, day out. A demand of this size calls for the most modern and efficient methods of extraction. Steel industry pits set a high standard. Before it can be used in steel making, the coal must be converted to coke, which is a stronger and more porous fuel. This is done in byproducts coke ovens. Larry cars charge 15.5 tons of the pulverized coal through the top of the oven. Gas is given off at the rate of some 50 million cubic feet a day, more than enough to supply the whole of Sydney and suburbs. This gas is reticulated all over the works for heating purposes. But first, valuable byproducts are extracted. Motor spirit, solvents, tar, fertilizer, naphthalene. After about 15 hours, the conversion is complete and the coke is pushed from the ovens. To quench one oven of incandescent coke, 17 tons of fresh water is showered on it in 1 minute. Of this, 7 tons goes up in steam, a fascinating spectacle which occurs every 6 minutes. The 3 major raw materials needed for iron making are now assembled alongside the blast furnaces. These furnaces are the smelting units in which the iron ore is reduced to metallic iron. The charge to the furnace consists of iron ore itself, coke as the heating element, and limestone. The latter turns to quicklime under heat, unites with the earthy matter of the ore and the coke ash to form a waste slag. Predetermined quantities are fed into the top of the furnace by means of a charging skip. The charge is subjected to a blast of hot air, which supplies the oxygen necessary to bring about the chemical reactions for the production of metallic iron. At 4-hourly intervals, the furnaces are tapped by piercing the tap hole at the casting floor level. The slag, being lighter, is skimmed off and run into ladles. Although of no use for steel making, it is valuable for road making when crushed, or is used for filling in the reclamation of land. The iron is run off into separate ladles and taken to the open hearth steel making furnaces or used for iron castings. Iron is refined into steel in the open hearth furnaces. Large quantities of scrap are used. Almost every steel article used by man has appeared on the scrap heap at some time. First, a charge of scrap, iron ore and limestone is placed in the furnace by charging machines and the full heat turned on. After about 3 hours, this first charge is melted and the iron, which has been kept hot meantime, is poured in. Often it is necessary to add more iron ore to the charge with spectacular results. In about 12 hours from the first charging, the furnace is ready to be tapped. To obtain the required composition, no alloys are added to the ladles of molten steel. Gradually, the steel is teamed from the ladles into ingot molds. When solid, the steel ingots are stripped from the molds and taken away to the rolling mills. On arrival at the rolling mills, the ingots, which have cooled on the outside, are placed in a furnace known as a soaking pit, where they're soaked with heat to bring them to a uniform temperature for rolling. The first and heaviest of the rolling mills is the bloom mill. The ingot is rolled back and forth until it is reduced to a section known as a bloom or slab. The bloom is then subjected to a process of reduction and shaping in a series of rolling mills. The 28-inch mill produces billets, heavy structural sections, and rails. The 18-inch continuous mill is a mill in which the steel is rolled continuously through a series of stands to provide feed for the smaller mills. These smaller mills include a 10-inch mill, which rolls scalp for the manufacture of pipes and tubes and the smaller steel sections. A rod mill for the production of rods for the manufacture of wire and wire products. And bright strip for such things as doorknobs, hinges, and innumerable other household and electrical articles used in our everyday life are made in the cold rolling department. The Australian steel industry manufactures many of its own special requirements to an extent not usual in other countries. Ferroalloys, necessary additives to the steel to meet the wide variety of grades called for. Rolls required in the rolling mills. The construction and manufacture of new plant and servicing and maintenance of existing plant calls for a wide variety of service departments. They include a well-equipped machine shop, foundry, and a number of other trade workshops. This work alone provides well-paid employment for some 2,000 men, apart from those directly engaged on steel production. Amenities include modern, well-kept bath and lunchrooms. Everything possible is done to ensure safe working conditions, and all new employees receive instruction before being allowed to start work. Hot-rolled rods are transported to the wire mills of Rylands Brothers, Australia Proprietary Limited, situated adjacent to the Newcastle Steelworks. The rods are cleaned in acid coated with lime, and then drawn through tungsten carbide dies to produce wire of hundreds of different shapes, sizes, and qualities. Most of the wire is drawn on modern continuous machines at speeds up to 3,000 feet per minute. Some classes of wire are given a protective zinc coating called galvanizing. 40 wires are run through continuously. Finished galvanized wires are wound onto blocks, and the coils are stripped off to be later tied, physically and chemically tested, and prepared for dispatch. Among many fascinating operations on these wire mills is the weaving of wire netting on mammoth looms. Barbed wire is manufactured by passing wires through these high-speed complex machines. In one of the most comprehensive wire mills in the world, and the second largest in the British Empire, barbed wire is only one of more than 800 different types of wire manufactured and put to thousands of different uses by Australian industries. Wire ropes for mining, office lifts, excavating, shipping and other equipment are made at the works of the Australian Wire Rope Works Proprietary Limited. The wire used in these is drawn from BHP steel at the Rylands wire mills. The nearby Lysats Works Proprietary Limited, manufacturers of flat and corrugated sheets, receives its raw material from the steelworks in the form of a sheet bar. After being cut to a length suitable for rolling, the bars are reduced to the desired thickness. Flat sheets, both plain and galvanized corrugated iron are produced. Pipes and tubes are produced at Stewart's and Lloyd's, Australia Proprietary Limited, from steel strip called skelp, rolled at the steelworks. The coils are first welded end to end to make a continuous run of strip. The strip passes through a furnace, emerges at welding heat, passes through rolls, which bend it to a circle and weld it. Over 4 miles of pipe every hour. High-pressure tubes are manufactured in the push bench plant from a steel section known as a bottle. A long steel mandrel is pushed through the bottle to form a stout-walled, seamless tube. The plant of Commonwealth Steel Company Limited, with its open hearth and electric steel furnaces, rolling mills and variety of equipment, is a major industry in itself. More than 140 grades of steel have been produced here. Specially selected scrap is charged into these electric furnaces, which are used for the making of high-grade alloy steels of all types. Our 2,000-ton press blanks out forgings for railway tires, which are further forged into shape by a steam hammer and then rolled in an electrically driven, hydraulically controlled tire mill. The complete wheels, tires and axles are manufactured. The greater part of railway requirements for Australia and New Zealand are met. A far cry from the blacksmith's hammer, this massive forge press exerts up to 5,100 tons pressure on a glowing ingot of special steel. The 60-inch ingot of alloy steel being forged was the heaviest made in Australia, and the finished forging weighed 12 tons. It is capable of handling forgings up to 150 tons in weight and is the largest press in the Southern Hemisphere. Special steels are rolled on the 30-inch bloom mill and the 12-inch merchant mills. The range of steels includes the popular and widely used stainless steel. The home, factory, office, hospital, train, railway car. This practical decorative steel has its uses for our comfort almost without end. Although the steel industry is a big industry, it depends for its wide variety of needs on thousands of outside suppliers, both large and small. Just as their part is important to steel making, so too are the jobs of their employees dependent on the steel industry. No other industry offers a wider variety of employment. You'll find accountants, engineers, loco drivers, all in the steel industry team. With vast expansion projects, opportunities are continually arising, and training sufficient young men is an important job. Yet the steel industry has had plenty of experience. In its modern research laboratory, skilled scientists and technicians explore every aspect of steel production and use. Over 70,000 Australians have a direct stake in this industry, 40,000 as shareholders and 30,000 as employees. $10,000 in Newcastle alone. The employees with total earnings of over 30 million yearly are well paid, their average being well above the overall for Australia. Thousands have found opportunity and a secure career in the steel industry service. Skillful, well-trained people, they're keeping pace with Australia's development, which mirrors the story of steel.